This is going to be section 16.6. We're going to be discussing the Carnot engine, the most efficient heat engine. So the Carnot cycle operates between two heat reservoirs, temperature T sub H and T sub C, and uses only reversible processes, so you don't lose any energy through an irreversible process. Its thermal efficiency is going to be defined as as thermal efficiency is normally defined. No engine operating between the same two temperatures can be more efficient than a Carnot engine. And all Carnot engines operating between the same two temperatures have the same efficiency. So what you're going to see here is that we're going to have isothermal compression, adiabatic compression, isothermal expansion, adiabatic expansion. And you will see it as it fluctuates between T sub H, which is this line, and T sub C. So let's take a look at the section. So in this process, for maximum engine efficiency, we must avoid all irreversible processes. So heat flow through a finite temperature drop is going to be considered to be irreversible. So therefore, during heat transfer in the Carnot cycle, there must be no finite temperature differences. When the engine takes heat from the hot reservoir at temperature TH, the working substance of the engine must also be at that same temperature. Otherwise, irreversible heat flow would occur. Similarly, when the engine discards heat into the cold reservoir, the engine itself must be at that temperature. So, every process that involves heat transfer must be isothermal. So conversely, in any process in which the temperature of the working substance of the engine is intermediate, in other words, in between those two, you can't have any heat transfer, because if you did, you would have an irreversible process. Therefore, any process in which the temperature T of the working substance must be adiabatic. So the bottom line here is that every process in our idealized cycle must be either isothermal or adiabatic. And in addition, thermal and mechanical equilibrium must be maintained at all times so that each process is completely reversible. This is not easy. The Carnot cycle consists here of two isothermal and two adiabatic processes. So if we look at our figure here, we've got a Carnot cycle using an ideal gas in a cylinder with a piston as its working substance. So we're going to start here at step one. The gas expands isothermally at a temperature T sub H, and it's going to absorb some heat. It's going to expand adiabatically until its temperature drops to T sub C. So as you go from, originally here it was from A to B, so A to B, then it lies along that same line. Now, as it falls in temperature, you're going to see it fall along this to a different isotherm from B to C. There's no heat exchanged, but there's work being done by the system. Now, third step, it compresses isothermally and it rejects a certain amount of heat. So you can see that Q sub C is less than 0, and there is work being done on the system. And then you see an adiabatic compression. No heat is exchanged, but work is being done on the system to raise the temperature back up. So if you look at the ratio of the heats that are absorbed, then the ratio of the temperatures are going to be related to that in this fashion. Also, if you go through and if you look at the thermal efficiency of this, it's going to be defined as this. And again, it's going to have no units. And this is valid only for absolute temperatures, Kelvin. So you've got some problems there to work through. Now, the Carnot refrigerator, because each step is reversible, the entire cycle may be reversed, converting the engine into a refrigerator. The performance coefficient is going to be obtained in the same manner. And then you can see those relationships here. And then if you substitute in the relationship between the heats that are exchanged and the temperature, you can see that the performance coefficient of a Carnot refrigerator is going to be given as such. No engine can be more efficient than a Carnot engine operating between the same two temperatures. That is just pretty much just comes from the fact that a Carnot cycle doesn't allow for irreversible processes to happen. Most other engines are going to allow that to happen.